I'll just go very quickly over a tool that we will talk mostly tomorrow. But the main idea for us was that this time around, rather than scaring you off and saying that you need to do this and that and this and that and this and that to get everything working, this time we will say, okay, what tools are out there that could facilitate you? So the tool I'm talking about today is a Cray-specific tool called Reveal. And today I'm going to only focus on what it tells you about vectorization. And most of the things you already know from the lectures today. But it's kind of a helper. You can think it sits with you and it helps you in some way, not always probably. So you'll see what I mean really. So I will not go through because I have a dentist appointment, and I'm sorry I'm very late. I was in a meeting. So you learned about the second part, the generation of annotated compiler listings, Intel and GNU at least, but you can also do the same for Cray and PGI. But most importantly, I will talk about Reveal. Has anyone heard about Reveal, Cray Reveal tool? Come on, you should not say that. And then I won't talk about this other one. So it's rather easy to use it. So you have been on Toady and Rosa. So essentially you need a couple of, few things. You need to have Cray environment, of course, because it's a Cray tool. Then you need to use the Cray performance tools because it gets feedback from your runtime information. Then there are a couple of more things you do. You compile your code with a few additional flags. Don't worry about looking at and trying to read anything here. We will go through that tomorrow a few more times, so you will know what you have to do. Then you run it, build the annotated code, run it. It should run as normal. You generate this, they call AP2 file, and you are done. So it may look like a few steps, but if you do it a few times, it's not that complicated. So just to recap, you do the programming module, you load perf tools, you compile to say that I want to generate a programming library and I want to generate a profile. Then you say, okay, I want to annotate my code so it can do the tracing. You run your executed instrumented output, which is usually with +pat, and you generate a report, and you launch Reveal with the program lib and AP2. So we will go through this many, many times tomorrow, so you will find it very, very easy to do after you have done a few times. So you just launch this command, Reveal program lib, and your AP2 file. And that's the thing you see. So up until now, the only thing you are seeing is on this side, you have some loops with some timings. Of course, you can click the middle button, try getting started if you are doing very first time. But since you are here, we can tell you pretty much the highlights. But if you want to learn more, you can, of course, click that part. So the most important thing to note here is you can click that top loops part, and it has 4 different views. So you can get a program view, you can get a top loops, you can get functional list, you can get array list. Tomorrow you will learn more about loops because we are doing more OpenMP tomorrow. But today I'm just going to show what it tells you about vectorization or any types of problems this tool sees about vectorization. So this is the program view. So it's like a top-down, which function is most expensive and which is least. So you can start clicking and opening, and it can go through the call tree very easily. And it always shows you how long some function takes and which loops are there. So you can just start clicking here and there. It won't break it for the most part, I guess. So that's where it becomes a little bit more interesting. So now I went back to top loops view, and I clicked on something that showed up to be a bit more expensive loop in the code. So I click it, and the bottom part, info, it has a red mark. So you can see it's red. Now we have a problem. It says a loop was not vectorized because it contains a call to a function on line 26. So it's really telling you why I cannot do it and what's the problem. But you already saw some of these things in other report. They may not be that verbose or clear, but in this tool, what they tried doing is giving you as much information as they can generate from output or profile or from the static code listing. So then, if I double click this thing appears. As Cray tells us, they are trying to write maybe more helpful information here, but here you can see that not only it tells you what the problem is on line number X, but reference to a non-vectorized user-defined or intrinsic function. And in this case, you will see on line, in fact, it's on line 27, you see that sout index is the function that is up there. We are not going to look in the code again. Here, have you done this Laplace example at all, Ben? No, okay. So let's just stick to the features, not necessarily what's in the code, because you will do this code tomorrow. And then if I click the line just below that, I see a green sign, a loop was unrolled. So I say, okay, I was managed to do something, but then, and then it says, okay, I was not able to vectorize something because the loop initialization was too costly. So it's telling us a little bit more about what it did and what it didn't do, what it couldn't do, and then if I double click something, it says that repeats the same message, but they say, okay, if you really, really want to, you can try forcing vectorization, and you can try and see that whether it helps or it doesn't help. Then I thought, okay, while we are doing something, I can show you where compiler is doing a little bit more, and here we have a directive that you learned, I think, a short while ago, and in this says, oh, I was able to do everything. I was able to unroll it. I was able to vectorize. And this loop should go much faster. And you will find out, hopefully tomorrow, that this is going to be the case. So I will skip this part because you have already learned that if the whole idea for us to tell you here, there is no like silver bullet. It's an iterative process. You do something, you run something, you modify, improve, and keep on doing it. And these tools, for example, Reveal is a more, how I can say, a sophisticated view of compiler listing with a bit more information. The Cray compiler listings are quite verbose, but information is scattered. So some is right in the beginning, some in the middle, and some towards the end. But it tells you really what it is doing, and then right at the beginning of the compiler listing, you will find this thing, and towards the end, there is all explanation. So through this tool, what they did is they provided a much user-friendly interface. Cray, Intel, you already did it. PGI, you can do something similar. And of course, you can change the verbosity of what the compiler tells you. GNU, again, the same thing, you saw that. So in summary, this talk was more about telling you what you are going to learn in more detail, not just vectorization, but with OpenMP using Reveal. We would really like you to try this tool tomorrow. But the other thing is, if you say, okay, we don't have a Cray platform, then we will tomorrow also review some Intel Cluster Studios tool. You can go on this link. I have copied my slides, so you should have my slides there. And you can see there are other tools similar to Reveal that are available on the Intel website. Of course, you have to buy them, but they can provide you similar level of feedback. So sorry for being late, and any question? I can take maybe one question, then I will probably run. Any question? No? Okay, thank you. Come on, you should not say that. And then I won't talk about this other one. So it's rather easy to use it. So you have been on Toady and Rosa. So essentially you need a couple of, few things. You need to have Cray environment, of course, because I was in a meeting. So you learned about the second part, the generation of annotated compiler listings, Intel and GNU at least, but you can also do the same for Cray and PGI. But most importantly, I will talk about Reveal. Has anyone heard about Reveal, Cray Reveal tool? Already know from the lectures today. But it's kind of a helper. You can think it sits with you and it helps you in some way, not always probably. So you'll see what I mean really. So I will not go through because I have a dentist appointment, and I'm sorry I'm very late. This and that and this and that and this and that to get everything working. This time we will say, okay, what tools are out there that could facilitate you? So the tool I'm talking about today is a Cray-specific tool called Reveal. And today I'm going to only focus on what it tells you about vectorization. And most of the things I'll just go very quickly over a tool that we will talk mostly tomorrow. But the main idea for us was that this time around, rather than scaring you off and saying that you need to do this,